So now in the last video, we looked at this circuit up here, not this down there. And we have a circuit, we got a 555 timer right there. The pin number 2 wants to hold the output high. Of course, the LED can't turn on unless the output goes low. But if you get the light dependent resistor dark enough, then you give a low input to pin number 4. That sets the output low and the LED can turn on. And so yeah, I went over that in the last video. Really long. And where did I put, there's the screwdriver. First off, let me see if I can get it to light up with this. So the goal is to light up this brighter LED. I forget how many, I think it's a 2-watt LED module right there. And so I think maybe if I cover this, the lamp is at the brightest setting right now. I might have to set it slightly lower. Let's see if I can, okay, that is enough to get the blue LED to light up. Otherwise, I'm dimming the lamp and I'm turning it off. I turned the TV off and everything. I didn't need to for the LED, but this one's going to be a tougher nut to crack. So we have a PNP bipolar junction transistor down here. So if you know the 2N2907, the NPN transistor, it can switch about 600 milliamps of current. This module at 12 volts, it's going to need like 200 milliamps of current. So I want something that can handle about 600. The 2N2904 and 2N2906 can only handle about 200 milliamps of current. This would push it to its limit. And so we got it wired as a switch. The emitter is up here, and then the base in the middle, of course, and then the collector down where that first pin is right there. So that is circuitry there. We can apply a higher voltage to this module, and then it will use less current. That's what that circuitry is for. But we can only handle up to about 12 volts on this one. I'm surprised that LED is, oh yeah, it's because the lamp's at the dimmest setting. When I had it at the brightest, it was not turning on. So we just need to set it to the output, and we're going to see how it does. So the blue LED is being protected by a 1000 ohm resistor, and we have a 1000 ohm resistor down here as well. And so we can get up to 12 volts. We need to for this module. So I will slide this over. We're done with the schematic. As I said before, it can get up to somewhere about around 200 milliamps of current. So I bumped this up to 300 right there. First off, let's see if I can switch it just like this. I don't think so. That's the dimmest setting. Looks like I'm actually going to have to turn the lamp off. And I don't know why. Oh yeah, the voltage is too low. That's right. I got to raise that. So I'm doing a lot of kind of troubleshooting here. So first, I can actually set the backlight on here. I don't know how well it's going to look, but I'll turn the light off there. So I also have it covered. I may or may not need it covered, but there you can see. Also, this creates light. So, you know, if I'll move my finger, okay, that didn't affect it. Now I'm going to slide it off. That affected it. So maybe it's because of that light. Yeah, looks like that light is the problem. That's the main problem right there. So you'd want to block off the light from the sensor. That may be the biggest problem. So again, a lot of this I'm just kind of testing out now as I make the video. And so, yep, current went down, that's good, as we raised the voltage right there. So that tells me that we're doing a pretty good job getting the transistor to turn on fully. And I may be wrong on that, but in any case, that's what we need. So higher voltage would mean less current, which is usually good as long as you don't exceed the current of any of the components. But we have 1000 ohm resistors right there, and their wattage is limited. So now we don't need the LED and the resistor up there. We just have the output coming to the transistor. It's a PNP bipolar junction transistor, though. We covered that in other videos. But normally I don't need 200 milliamps of current. So I usually use the 2N2906 because I also use the 2N3904 in a lot of circuits. And not everybody has the 2N2907. They usually have a 2N3906 and a 2N3904. that's the main reason why I use those two transistors. But that's really about it. It can handle more current. I think this makes a better switch than the 2N2906. But for most circuits, you can use either of them. Here we need more current. 200 milliamps is the absolute limit for the 2N3906, and that would push it all the way to its max, which usually you want to avoid. You know, for short period of times it probably won't affect the component, but when you're steadily keeping the current maxed, it's probably going to burn out, you know, and not too terribly long of a time. Try to stay below half of the maximum current on the majority of items. Remember, it's a maximum for a reason. Not really intended to be like that all the time. So in any case, yeah, that's it. I wanted to do this. I tried to do this with the op amp LM358. It can also go up above 15 volts. But I don't think it could deliver the current needed. This is a 1000 ohm resistor, by the way, because we need to switch 200 milliamps of current approximately. So instead of like the 20 that I need for an LED, usually less than 20. So 10 times the current means we're going to try to get 10 times as much base current. Usually I use like a 10,000 ohm resistor. I dropped it down to a 1000 ohm resistor right there. And also, I'm not sure how well this will do turning on an NPN bipolar junction transistor. You lose a little bit of voltage coming out of the output, but it does look like this turns on fully at 10 volts. I will lower this. And so in any case, I like to just kind of do these random videos every once in a while. The ones where I make a diagram from scratch, I've been reusing diagrams because I can crank them out. I want to try to go a day, or try to go without having a day where I don't have 2 videos. And so I'm cranking out a bunch right now. Once I have a bunch of days filled up with 2 videos, then I'll make some more diagrams and stuff and come up with other topics. But otherwise, I don't mind also just kind of quickly throwing something together like this. It only really took about as long as it took to make this video, other than a couple practice circuits before. So hope that all made sense. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. I'm going to put that to 5 volts because that's usually where I have it. And I'm going to turn the, oops, I have to set that. I'm going to turn the light off. Alright, see you in the next one.